in this video, I am going to discuss about Shapiro reaction. Shapiro reaction. So, Shapiro reaction converts the tosyl hydrazones into alkenes. They convert tosyl hydrazones into alkenes in presence of N-butyl lithium, or sometimes LDA can also be used, and both these reagents are the strong bases. They are the strong bases. So how are we going to get this tosyl hydrazones? So we know the reaction, that is carbonyl compounds, either an aldehyde or a ketone will react with hydrazine. That is, we'll have a lone pair of electrons on the nitrogen, will attack on the electrophilic carbon of the carbonyl compound, and water is removed and we get double bond N and NH2. This is the hydrazone. So in the similar way, tosyl hydrazones are obtained by reacting the ketone or aldehyde with tosyl hydrazine. Then we get, this is the tosyl hydrazine. So the tosyl is abbreviated as TS, and that is the tosyl, and this is a leaving group. This is the leaving group. So this reaction uses two equivalents of butyl lithium, two equivalents of N-butyl lithium is used in this reaction. So let us look at the mechanism. So let us take any tosyl hydrazine. R1, R2 and R3. So the first mole of butyl lithium will abstract the most acidic proton, that is the NH, and we get the anion. So we also have a hydrogen over here, and the second mole of butyl lithium will deprotonate this hydrogen, and we get the di-anion. So we have a negative charge. So this is a di-anion over here. So this negative charge moves on to the here, and the double bond is pushed on to this bond, and this tosyl group leaves out. So then we are going to get R1. You have a double bond over here, and then N double bond N minus. R2. So on this the negative charge on the nitrogen is pushed on to here, and this bond moves here, and we get the carbon ion or the negative charge on this bond, and R3. So if you add any of the electrophile, then we are going to get the alkene. So here if you do the workup, so that is pour it into water, then we get H plus as the electrophile, and the corresponding alkene we get. So the other electrophiles that can be added, or you can add any of the aldehyde or the DMF, or we can as well do the alkylation reactions. So here the product that is formed, is kinetically controlled. So as the second deprotonation occurs syn to the aryl sulfonamido anion. So therefore we get the less substituted alkene. So this is about the Shapiro reaction, and in the next video we will look into certain examples with problems.